Hello everyone, my name is Rupashri and I am from CSCD, bearing roll number 5A naught. Now we are going to discuss about graph. In this, we are going to see the definition of graph, examples of graph, and complete graph, subgraph, and the degree of the. Now we'll see what is the definition of graph. A graph is a set of vertices and edges. A graph contains two sets, a finite non-empty set of vertices V of g, a finite possible set of edges E of g. Now we'll see. In this, we are going to see the types of graph. Basically, the graph is of two types: undirected graph and directed graph. Undirected graph. An undirected graph is one in which the pair of vertices in an edge is unordered. That means the direction is not defined. Directed graph. Directed graph is one in which each edge is a directed pair of vertices, which means the direction is directed toward a specified vertex. In this, we are going. Now we will see what is a complete graph. A complete graph is a graph that has maximum number of edges. For undirected graph with n vertices, the maximum number of edges is n of n minus 1 by 2. For directed graph with n vertices, the maximum number of edges is n of n minus 1. Example, we'll see in the next slide. Now we'll see the examples of graph. In the before slides, we came across the complete and incomplete graph, directed and undirected graph. Now let us look at each of the examples. In the graph G1, the number of vertices are 4, which are 0, 1, 2 and 3. Here the edges are 0, 1, 0, 2, 0, 3, 1, 2, 1, 3, 2, 3. Here the number of edges are 4. Number of vertices are 4, and it is an undirected graph. So we have to see whether it is complete or incomplete by substituting in the formula n of n minus 1 by 2. Here the vertices are 4, so 4 of 4 minus 1 by 2, 6. Here the edges are 6, so it is a complete graph. And now we will see the second example, the graph G2. Here the vertices are 0, 1, 2, 3, 4, 5 and 6. Here there are 7 vertices. Let us see whether it is a complete or incomplete. Here it is. Directly we can examine that it is an undirected graph, and the formula for undirected graph is n of n minus 1 by 2. N equal to 7. 7 of 6 by 2, 21. But here there are no 21 edges given. Now, so it is incomplete graph. Now let us see the third example, graph G3. The vertices are 0, 1, 2. There are 3 vertices, n is 3, and it is a directed graph. So formula to find whether it is complete or incomplete for a directed graph is n of n minus 1. So n is 3, 3 of 2, 6. Here we have only 3 edges possible, that is 0, 1, 1, 0, 1, 2. So we require 6 edges to be a complete graph, but in this they gave only 3 edges, so it is an incomplete graph. So from this, the complete graph is G1 and the incomplete graph is G2 and G3. Now we'll see what is the subgraph. A subgraph of G is a graph G dash such that V of G dash is subset of V of G and E of G dash is subset of E of G. Now we'll see what is path and how to see the length of the path. The length of the path is the number of edges on it. Now we'll see what is the degree of the graph. The degree of your vertex is the number of edges incident to that vertex. For directed graph, the in-degree of your vertex V is the number of edges that V has the end, and the out-degree of the vertex V is the number of edges that have V as the tail. If di is the degree of the vertex I in a graph G with n vertices and e edges, the number of edges is calculated by using the formula E equal to sigma 0 to n minus 1 d of phi by 2. Now we'll see what is the degree of the graph.